approximating area under the curve. Let's say we are given a function f of x is equal to minus x square by 2 plus 3. And what we have to figure out is the area under the curve from minus 2 to 2. Okay. Now, just so that we can visualize it, let's put up the graph. Now here, this is the graph of this function, and from minus 2 to 2, we have broken up the area under the curve into 4 regions, right? From minus 2 to minus 1 to 0, 0 to 1, and 1 to 2. Okay, so now there are different ways in which we can figure out this area. One way is to look at the left hand side. This would be the rectangle formed, this would be the rectangle formed. We just have to focus on the left hand side. Okay, and left hand side is this. And now we figure out the area of the rectangles. So naturally there will be some underestimation or overestimation. Yes, so it would be an approximation when we calculate the area under the curve using this method. So this was, if we look at it from the left hand sides. If we look at it from the right hand sides, what will happen? It will be like this. It would be like this. Okay. Or what we can do is look at it from the midpoint of view. Right. So midpoint would be somewhere here. Similarly, here. Similarly, here. And somewhere here. Okay. Or what we can do is look at it from, and instead of looking at it from rectangles point of view, let's look at it from trapezoids. Trapezoids would be like this, straight lines connecting the endpoints of each interval. So as you notice, each of these will give us a different level of approximation. This was based on the graph. Now suppose we don't have a graph and it is complicated enough for us not to spend time on creating the graph. Then what do we do? Now let's say we don't have the graph. So what do we do? First we figure out all the, we decide how many number of intervals we want. So let's say the intervals are minus 2 to minus 1, minus 1 to 0, 0 to 1, and 1 to 2. So that means 4 intervals. So if it is minus 2, what will it be? Minus 2 square is 4, minus 4 by 2 is minus 2, minus 2 plus 3 is 1. Similarly, if it is minus 1, then this would be 2.5. If it is 0, it will be 3. If it is 1, 2.5. If it is 2, it would be 1. Okay, so we have these values. Now let's figure out the area approximately. So let's focus on the left endpoint of each interval. Okay, so in that case, what happens? Left endpoint would be, if we talk of minus 2 to minus 1, then the area would be 1 is the width times the height. Height we have to take the left endpoint, and that is 1. So 1 times 1 is 1. Now the next interval is minus 1 to 0. So this would be 1 times 2.5, which would be 2.5. So let's say this is 1.0. Then we have 0 to 1. In that case, width again is 1 and height is going to be 3, which gives us 3.0. And from 1 to 2, we will get 1 times, this would be 2.5, which is equal to 2.5. If we add up all these areas, what do we get? We get 2 plus 1, 3, 3, 6, 6 plus 3, 9. So 9.0 will be the square units, whatever it is. Now, if we take the right endpoints, then in that case, minus 2 to minus 1 would be width is still 1 times 2.5, which would be 2.5. From minus 1 to 0, it would be 1 times 3, which gives us 3.0. Then 0 to 1 would be, again, width is 1 and 2.5 would be the height, which gives us 2.5. And from 1 to 2, we will have 1 times 1, which is equal to 1.0. If we add it up, what do we get? 2.5, 2.5, 5. 5 plus 3, 8. 8 plus 1, 9.0. Okay, this is the second approximation using the second method. Now, instead of looking at left endpoint or right endpoint rectangles, let's look at trapezoids. In case of trapezoids, minus 2 to minus 1, this would be, remember the formula for finding the area of a trapezoid is average of the two parallel sides times the altitude. That is the distance between these two parallel lines. So that would be 2.5 plus 1 by 2 times 1, which gives us 3.5 by 2, that is 1.75. Then we have minus 1 to 0. This would be 3 plus 2.5 by 2 times 1, which gives us 5.5 by 2. That would be 2.75. 0 to 1, it would be 2.5 plus 3 by 2 times 1, which would again be 5.5 by 2, that is 2.75. And from 1 to 2, it would be 1 plus 2.5 by 2 times 1, which would be 3.5 by 2, that is 1.75. And if we add up all these, we get 9.00. Okay, now here we are getting all the approximations as 9.0. That is happening purely, in this particular example. As we will see in the next example, it may vary. Okay, so let's look at the second one. F of x is equal to minus x by 2 plus 3 in the interval minus 2 comma 2. Okay, so let's evaluate f of x. Minus 2 will be 4, minus plus 2 by 2 is 1, 3 plus 1 is 4, minus 1 will be 3.5, 0 will be 3, 1 will be 2.5 and 2 will be 2. Okay, so let's evaluate the area using the right endpoint. Okay, so now this would be from minus 2 to minus 1. This would be 1 times width is 1 and 3.5 right handed. Okay, which is 3.5. Let's say 0. Then minus 1 to 0 would be 1 times 3, which is 3.00. From 0 to 1 will be 1 times 2.5, which would be 2.50. And from 1 to 2, it will be 1 times 2, which would be 2.00. And if we add it all up, we get 0, 0, 1, 2 plus 1, 3, 3 plus 2, 5, 5 plus 6, 11. So 11 square units will be the approximate area. under the curve between minus 2 and 2. So similarly, let's look at using the left endpoint method. Now here minus 2 to minus 1 will be 1 times 4, which is equal to 4.00. Okay, minus 1 to 0 would be 1 times 3.5, which is 3.50. 0 to 1 will be 1 times 3, which is equal to 3.00. And 1 to 2 will be 1 times 2.5, which is 2.50. And if we add it all up, we will get how much? 0, 0, 1, 3, plus 3, 6, plus 3, 9, plus 4. So here if you notice, the approximate values are varying between different methods. And let's very quickly do it using trapezoid method. Minus 2 to minus 1 would be, remember, average and then times the altitude, average of the lengths of the parallel sides. So this would be 7.5 by 2 times 1, which is 3.75. Minus 1 to 0 would be 6.5 by 2 times 1, which would be 3.25. 0 to 1 will be 5.5 by 2 times 1, which is 2.75. And finally, from 1 to 2 will be 4.5 by 2 times 1, which is 2.25. If we add it all up, we will get 12.00. So using all the three methods, we get different approximations. So that is the second problem. Let's look at the third problem. Let's look at the third one. The third one is f of x equal to x squared plus 2x plus 3 in the interval minus 2 to a. So x, f of x. Again, we break up as usual. See, if the intervals are different, we need to be careful about that. So here again, we break it up into 4 parts. Minus 2 to minus 1, minus 1 to 0, 0 to 1, 1 to 2. So minus 2 will give us 3. Minus 1 will give us 2. 0 will give us 3. 1 will give us 6. And 2 will give us 11. So now let's use the right endpoint, figure out the area. So minus 2 to minus 1 will give us a right endpoint. So that would be 1 multiplied by 2 gives us 2, minus 1 to 0 gives us 1 times 3, which is 3, 0 to 1 gives us 1 times 6, which is 6, and 1 to 2 will give us 1 times 11. Add it up, we get 11 plus 6, 17, 20, 22. If we use the left endpoints, what do we get? We get minus 2 to minus 1 will give us 1 times 3, which is 3, minus 1 to 0 will give us 1 times, what is it? 2, which is 2, and 0 to 1, 1 times 3, which is 3, and 1 to 2 will be 1 times 6, which will be 6. And this will give us 6 plus 3, 9, plus 2, 11, plus 3, 14. So as you can see, a very wide discrepancy between these two approximations. F of x is equal to x square plus 3 in the interval minus 3 to 1. So here the interval has changed. Okay, so f of x, let's say -3 to this will give us 12. 9 plus 3, 12. -2 will give us 7. -1 will give us 4. 0 will give us 3. And 1 will give us 4. Okay. So now write endpoint. So -3 to -2. So again the intervals will be -3 to -2, -2 to -1, -1 to 0, 0 to 1. Okay, this would be the width remains the same. So 1 times 7 is 7. This would be 1 times 4, which is 4. 1 times 3, which is 3. 1 times 4, which is 4. And if we add it up, we get 7 plus 4, 11, 11 plus 3, 14 plus 4, 18. Yes. And if we take the left end point, we get again -3 to -2, -2 to -1, -1 to 0, and 0 to 1. So this would be 1 times 12, which is 12. 1 times 7, which is 7. 1 times 4, 4. 1 times 3, which is 3. And here again there seems to be a wide difference between these two approximations. 12 plus 4 is 16, 16 plus 3 is 19, 19 plus 7 is 26. Okay, f of x is equal to 4 by x in the interval 2 comma 6. Now here you have to be careful, right? Because x is in the denominator, x cannot be equal to 0, right? And this 0 should not belong to 2 comma 6, right? So be careful about that. Now since it doesn't belong, so 0 does not belong to 2 comma 6, we are perfectly fine with this. So x, f of x, if x is 2, this will be 4 by 2, that is 2. If it is 3, it will be 4 by 3. If it is 4, this would be 4 by 4, that is 1. If it is 5, 4 by 5. And if it is 6, it will be 4 by 6, that is 2 by 3. Okay. So now let's look at the area using left end point. Okay. So 2 to 3 would be, width is 1 times 2, which is 3 to 4. Be 1 times 4 by 3, which is 4 by 3. 4 to 5, 1 times this would be 1, which is 1. And 5 to 6 will be 1 times 4 by 5. And if we add it all up, what do we get? We get 31 by 6, which is equal to 6 5 30 point. 1 is remaining, so 10, 6 1 6. Again 4 is remaining, so 6 6 36. Okay, so approximately this is what the value is of the area using the left endpoint method. Now let's look at it from right endpoint. Then 2 comma 3 would be 1 times 4 by 3. 3 to 4 would be 1 times 1. So this would be 4 by 3. This would be 1. 4 by 4 to 5 will be 1 times 5 by 6, which will be 5 by 6, and 5 to 6 would be 1 times 2 by. Okay, now here what do we do? If we add it up, we get 23 by 6. So 6 3s 18, 5 is remaining. So 50. 50 means 6 8s 48. So 2 remaining, 6 6 30. No, not 6 6. 6 3s 18. And this will repeat. So this is the area in square units. So again, a big difference. Okay, now let's look at the sixth one. Of x is equal to 5 by x square in the interval 1 comma 6. Okay, again x cannot be equal to 0, but since 0 does not belong to 1 comma 6, we are safe. So x, f of x, if it is 1, this will be 5. If it is 2, this will be 5 by 4. If it is 3, this would be 5 by 9. If it is 4, it will be 5 by 16. And if it is 5, it will be 5 by 25, which is 1 by 5. And 6, it will be 5 by 36. Okay, one extra is there here. One extra interval because it is 1 to 6. Okay, now let's look at it from the left end point. So 1 comma 2 will be 5. 2 to 3 would be 5 by 4. 3 to 4 would be 5 by 9. 4 to 5 would be 5 by 16. 5 to 6 would be 5 by 25. That is 1 by 5. Yes. Now if we add it up, we get 7.3. Okay, now if we take the right end point, we get 1 to 2, 5 by 4. B would be 5 by 9. 3 to 4 would be 5 by uh, 16. 4 to 5 would be 5 by 25, that is 1 by 5. And 5 to 6 would be 6 by 36. 5 by 36. 5 by 36. And if we add it all up, we get 2.36. So again, a big difference in the approximations. Okay, in that case, 1 to 2 would be 5 plus 5 by 4 by 2 times 1. So I'll ignore writing times 1. Okay, so here we have 5 times 5 by 4 by 2. So this gives us 3.12 will give us 5 by 4 plus 5 by 9 by 2. This gives us 0.903. 3 to 4 gives us 5 by 9 plus 5 by 16 by 2, which gives us 0.434. And 4 to 5 gives us 5 by 16 plus 1 by 5 by 2, which gives us 0.256. 5 to 6 gives us 1 by 5 plus 5 by 36 by 2, which gives us 0.169. And if we add it all up, we get 4.887, which is seems to be much more closer to the real one, the actual area. Okay. And usually trapezoids will give you a much better approximation than the left and the right endpoint method. Let's do the seventh one. Of x is equal to x by x plus 1 in the interval 0 to 3. Now here, the moment you see an x in the denominator, ensure that the denominator cannot be 0. So x plus 1 cannot be equal to 0. That means x cannot be equal to minus 1. And fortunately for us, the interval is such that minus 1 does not belong to 0, comma 3. So we are safe. So let's begin x and f of x 0 to 3. So 0, 1, 2, 3. If it is 0, this would be 0. If it is 1, it will be 1 by 2. If it is 2, it will be 2 by 3. And if it is 3, it will be 3 by 4. Okay. So now let's directly go for trapezoid. As I mentioned previously, this gives a much more accurate approximation. Okay, so 0 to 1, what would be the area? Area would be 0 plus half by 2 times the distance between the two parallel lines, which is 1. So this will give us 1 by 4. 1 to 2 will give us 1 by 2 plus 2 by 3 by 2 times 1, which gives us 5 by 12. And 2 to 3 will give us 2 by 3 plus 3 by 4 by 2 times 1, which is 17 by 24. And if we add up all these fractions, we get 33 by 24, which gives us approximately 1.375. Okay, so that is the area under the curve in this interval. Okay, let's look at the eighth one. F of x is equal to minus x by x square plus 1, and the interval is minus 1 to 2. Okay, and since in the denominator we have a x square and this is addition, so it will never be 0. So let's say x and f of x minus 1, 0, 1 and 2. If it is minus 1, we get minus 1. We get minus minus 1, 1 by 2. 0 gives us 0, 1 gives us 1 by minus 1 by 2, and 2 gives us minus 2 by 5. Okay, just to make sure, minus 2 divided by 2 square is 4 plus 1, 5. Okay, again we will use trapezoid method. In the interval minus 1 to 0, we get half plus 0 by 2, which gives us 1 by 4. And from 0 to 1, it gives us 0 plus minus half by 2, which gives us minus half by 2, which is minus 1 by 4. And from 1 to 2, it gives us minus 1 by 2 minus minus 2 by 5 by 2, which gives us minus 9 by 20. Okay, and if we add up all these, we get minus 9 by 20 because these two get cancelled out. And this is approximately equal to 0 minus 0.45. Now, very important point is whenever we are trying to figure out the area under a curve, we might encounter a situation where the graph goes something like this. right? So here we may be interested in the area from here to here. So this will be positive area purely based on calculations, and this will be negative. So depending on the context, you decide what to do, right? If the overall area is negative, it will give you a negative area. But the area itself can't be zero. But depending on the type of problem that you're trying to solve, you may either ignore it, the negative sign, and basically add all these individual areas, right? All these individual areas you add, in which case this minus gets becomes plus. So you add up all of them, ignoring the negative signs. But purely based on the method that we have followed, the area would be minus 0.45. Otherwise, if we are going to ignore the negative part, so it will be 1 by 4 plus 1 by 4 plus 9 by 20. So we would be taking the absolute values of these individual areas. So which gives us 2 by 4 plus 9 by 20, which gives us 4 5 10 plus 9 by 20, which is 19 by 20. So this would be, if we don't ignore negative areas, we basically add this negative area to the other areas. Here, this will be the case when we ignore the negative signs and basically add up all of them, or rather we take the absolute value of those areas. Ninth one, f of x is equal to natural log of x, and here x cannot be less than or equal to 0, but the interval that is given to us is 1 by 4. So x does not belong to the interval 1 by 4. So we can proceed. So now x and f of x. So we have 1, 2, 3, 4 equidistant. So if it is 1, natural log of 1 is 0, natural log of 2 is 0.69, natural log of 3 is 1.10, and natural log of 4 is 1.39. So here, to figure out these natural logs, we can use the calculator. Okay. Now again we are going to use trapezoid method. So 1 to 2 would be 0 plus 0.69 by 2 times 1. In the previous example, I didn't mention 1 because till now we have been looking at intervals of 1. Okay, so this would be equal to 0.345. 2 to 3 would be 0.69 plus 1.10 by 2, which gives us 0.895. Again, from 3 to 4 will be 1.10 plus 1.39 by 2 times 1 equal to, this comes to 1.245. And if we add up all these, we get 2.485 square units. That is the area. Okay, 10th one, f of x is equal to natural log of e to the power of x. Okay, in the interval -2 to 1. Now, if you notice, this natural log and e will cancel out each other. So it is as good as saying f of x equal to x, right? It is just a different way of writing it. So x and f of x. So if it is -2, it will be -2 because it's a standard linear function. -1, -1, 0, 0, 1, 1. And again, using the trapezoid method, we get areas as -2 to -1. Area would be -2 plus -1. So -1 by 2, which gives us -3 by 2. from -1 to 0. It gives us -1 to 0 by 2. So this gives us -1 by 2. And from 0 to 1, we get 0 plus 1 by 2, which is equal to 1 by 2. And finally, is that all? Yes. So now we add up all these fractions. What we get is -3 by 2 square units, which is nothing but minus 1.5 square units. Again, as I mentioned in the previous example, depending on the context, you might take the absolute value of these individual areas. In which case this becomes 3 by 2 plus 1 by 2 plus 1 by 2, which gives us 3 plus 1 plus 5 by 2 square units. But mathematically, this is the area. Okay. Now the next one, that is 11th one. F of x is equal to natural log of 5 by x. Now here 5 by x cannot be less than or equal to 0, or we can just say cannot be equal to 0. Okay. And the interval that is given to is 1 comma 4. So this will never be equal to 0. X will not be equal to 0. So x f of x 1 to 4, so 1 2 3 4. Natural log of 5 is 1.609. Natural log of 5 by 2 is 0.916. Natural log of 5 by 3, natural log of 5 by 3 is 0.511, and natural log of 5 by 4 is 0.223. So again, using the trapezoid method, we get area from 1 to 2, 1.609 plus 0.916 by 2 times 1, which is equal to 1.26. Similarly, 2 to 3 would be 0.916 plus 0.511 by 2, which gives us 0.71. And from 3 to 4, it gives us 0.511 plus 0.223 by 2, which gives us 0.37. And if we add up all these areas, we get 2.34. Remember, these are all approximations because each individual step involved approximations. Okay, now let's look at, this was 11th, 12th one. F of x is equal to e to the power of x from -2 to 1. Okay. Now here there is no restrictions. So let's take x and figure out f of x. Interval is -2 to 1. So -2, -1, 0, 1. If it is -2, we get e to the power of -2, which is equal to 1 by e to the power of 2. If it is -1, this is equal to 1 by e. If it is 0, it is e to the power of 0, which is 1. And if it is e to the power of 1, this is, do not take the value of e itself. Let it be e, and let's, as the last step, we might decide to actually substitute the value of, okay, so -2 to -1 would be 1 by e square plus 1 by e divided by 2. So if we evaluate this, we get 1 plus e by 2 e square. Okay, and the gaps are, again, the intervals are in increments of 1, so times 1. Area in the interval -1 to 0 would be 1 by e plus 1 by 2, which gives us 1 plus e by 2e. Again, times 1 is there, we can, okay, from 0 to 1, this would be 1 plus e by 2. Okay, so we have these individual areas. Now let's add up all these. We can just leave it at this and say this is the area under the curve. But if you use the calculator and actually evaluate it, it will come to approximately 2.79 square units. F of x is equal to sine of x in the interval pi by 4 to pi. Okay, now let's partition the interval into uh, equal parts. So let's start with x with pi by 4, then pi by 2, then 3 pi by 4 and pi. So the distance between each of these is pi by 4. So f of x would be pi by 4 is going to be 1 by root 2, pi by 2 is 1, 3 pi by 4 is 1 by root 2 and pi is 0. So again trapezoid method. In the interval pi by 4 to pi by 2, the interval, the area would be 1 by root 2 plus 1 by 2 times the distance between these two. And the distance between these two is what? Pi by 4. Then from pi by 2, 3 pi by 4 is going to be 1 plus 1 by root 2 by 2 times pi by 4. And from 3 pi by 4 to pi, it would be 1 by root 2 plus 0 by 2 times pi by 4. Okay. So now we need to evaluate each of these quantities. Now this would be 0.67. These two are same, so 0.67. And this would be 0.28. And if we add up all these, what do we get? So 7 plus 8, 15, 15 plus 7 is 22, 2, 2 plus 2, 4, 4 plus 6, 10, 10 plus 6, 16, 1, 1.62 square units. That would be the approximate value of the area. Now the 14th problem. F of x is equal to tan of x in the interval minus pi by 4 to pi by 4. Okay. And you can figure out whether it is a valid values or not. Remember the graph of the tan x. So now let's take x, let's take f of x. If it is minus pi by 4, this would be minus 1. If it is minus pi by 6, this will be minus 1 by root 3. If it is 0, this will be 0 here. If it is pi by 6, it will be 1 by root 3. And if it is pi by 4, it is going to be 1. Now here, the distance between these two intervals is pi by 12, 15 degree, right? Here it is pi by 6, 30 degree. Here it is pi by 6, 30 degree. And here it is pi by 12. The reason I have kept uneven intervals is primarily because I want to stick to the standard angles. Okay, so let's evaluate the area. Okay, from minus pi by 4 to minus pi by 6. The area would be minus 1 plus minus 1 by root 3 by 2 times pi by 12. which gives me minus 0.206. Okay, now minus pi by 6 to 0 gives me minus 1 by root 3 plus 0 by 2 times pi by 6, which gives me minus 0.151. Then 0 to pi by 6 will give me 0 plus 1 by root 3 by 2 times pi by 6, which is equal to 0.151. And pi by 6 to pi by 4. And again here it will be 1 by root 3 plus 1 by 2 times pi by 12, which would be 0.206. Here this and this cancel, this and this cancel, so the area is 0 mathematically. If you ignore the minus signs, then the area would be 0.715. So be clear whether you have to give the mathematical answer or the context specific answer. Okay. Even without doing all these calculations, we could have figured out at least the mathematical answer, because we know tan is a function which is symmetric across the origin, right? And the interval that is given is also minus pi by 4 to pi by 4. So that means both the areas will be equal across the origin. So they will both cancel out and the answer would be 0. Okay. 15th problem. F of x is equal to x cube plus 2x square in the interval minus 2 comma 1. Okay, x and f of x. Minus 2, minus 1, 0, 1. Minus 2 would be, this will be 0, this will be 1, this will be 0, this will be 3. Okay. Again, we will use trapezoid method. And in the interval minus 2 to minus 1, it will be 0 plus 1 by 2, which is 1 by times 1 also is there, but that doesn't have an impact, so I'm ignoring it. But you have to be careful when to ignore it. Only if it is 1, you should ignore it, or you can just show it as times 1. Okay, now minus 1 to 0, this would be 1 plus 0 by 2 times 1, which is 1 by 2. And from 0 to 1, this would be 0 plus 3 by 2 times 1, which is 3 by 2. And if we add up all these, we get the area, which is 5 by 2, which is 2.5. Actually, the exact area is 2.25. Okay, 16th one. F of x is equal to cube root of x in the interval minus 2 to 2. Now, again, x, f of x, minus 2, minus 1, 0, 1, 2. If it is minus 2, then it will be minus 1.26. If it is minus 1, it will be minus 1, 0, 0, 1, 1, and 1.26. Again, trapezoid method. So in the interval minus 2 to minus 1, it would be minus 1.26 plus minus 1 by 2 times 1, which gives us minus 2.26 by 2, which is minus 1.13. Again, minus 1 to 0 will give us minus 1 plus 0 by 2, which is minus 1 by 2. 0 to 1 would be 0 plus 1 by 2, which is 1 by 2. And from 1 to 2, it would be 1 plus 1.26 by 2, which is 2.26 by 2, which is 1.13. Okay, so if we add up all these, we get 0 as the area. But if we take the absolute values, the area would be 3.26. Okay. So that was the 16th one. 17th one of x is equal to square root of x square plus 1 by x. Now here x cannot be equal to 0 because the interval given to us is minus 10 to 10 and 0 belongs to this interval minus 10 to 10. So directly we cannot do it. But if we notice, if we instead of x, if we say minus x, we get square root of minus x square plus 1 by minus x, which is equal to square root of x square plus 1 by x minus. So which means it's an odd function, which means it is symmetric across the origin. So it would be something like this. If the graph is like this, then this would be like this, right? So if we can figure out one side, double of that will be the uh, area of both the sides included, or it will be 0, depending on the context. What we are looking at. Okay. So here, mathematically speaking, area would be 0. Area is 0 only if the here we have given minus 10 to 10. Both these points are equidistant from the origin. Then only we can say the area is 0. If they are not equidistant, then we can't say it is 0 and we can't evaluate it. Okay, 18th one. F of x is equal to natural of x by cos x. Okay, and the interval that is given to us is 2 pi by 3 to 4 pi by. Okay, now here cos x cannot be equal to 0. That means x cannot be equal to pi by 2, or it can't be 3 pi by. These two do not belong to the interval 2 pi by 3 and 4 pi by 3. So we are safe. So let's figure out x and f of x. So x would be 2 pi by 3, 5 pi by 6. Now here the intervals are 30 degrees. 5 pi by 6 pi, 7 pi by 6 and 4 pi by 3. And f of x would be minus 1.48 minus 1.11 minus 1.14 minus 1.50 and minus 2.86 using the calculator. So now again using the trapezoid method, let's figure out the areas in the intervals 2 pi by 3 to 5 pi by 6. This would be minus 1.48 minus 1.11 by 2 times pi by 6 is the common interval. Okay, this would give us minus 0.67. In the interval 5 pi by 6 to pi would be minus 1.11. No, this will become minus 1.11 minus 1.14 by 2 times pi by 6, and this would be minus 0.59. In the interval pi to 7 pi by 6, this would be minus 1.14 minus 1.5 divided by 2. This would give us minus 0.69, and from 7 pi by 6 to 4 pi by 3 would be minus 1.5 minus 2.86 by 2, which gives us minus 1.1. All are negative, so we can just directly add them up. If we add them up, we get 3.09 minus. So mathematically, the area is minus 3.09. But again, depending on the context, you would take the absolute values. So that is approximating area under the curve. That's it. Bye.